Section 6.5 and 6.6 talks about the law of sines and the law of cosines. So our goal now is to, what we learned in the previous sections, we learned how to solve for right triangles, okay? Now what we're going to do in this section, we're going to learn how to solve for oblique triangles, okay? Which are triangles that have no right angles, okay? So in standard notation, the angles are labeled with capital letters, A, B, and C. Their opposite sides are labeled with lowercase letters, little a, little b, and little c. So here you have A, B, C, and then you have little a, b, c, okay? So now, to solve an oblique triangle, you need to know the measure of at least one side and any two other parts of the triangle. You need to know the measure of at least one side and any two other parts of the triangle, okay? The possible cases that you can have are, these are the four cases, okay? You can have two angles and any side. You can have two sides and an angle opposite one of them. That's important. You can have three sides, and you can have two sides and their included angle. Okay? So you can have two angles and any side. You can have two sides and an angle opposite one of them. If you are in one or two above here, then you're going to use the law of sines, which I'm about to introduce. If you have three sides, or if you have two sides and their included angle, then you're going to use the law of cosines. Okay? So, let's learn what these laws are. The law of sines. The law of sines says in any triangle, the ratio of the sine of an angle to the length of its opposite side is constant. So sine of capital A over little a is equal to sine of capital B over little b, and sine of capital C over little c, or that's equal to sine of capital C over little c. Okay? Equivalently, you can write the sides on top of sine of the angle. Okay? You can do that. You have equality. Yes?
Can I see the third
Sure.
side and angle thing?
Yes.
Thank you.
You're welcome. Did you have a chance to write down the law of sines?
I did, thank you.
Okay. So the law of sines now, we know what that is. Now let's apply it. Remember the four cases. We're going to be referring to those four cases throughout the remainder of class whenever we talk about examples. Okay? So, example 1. Example 1, we're given this triangle. You have angles 30 degrees, 135 degrees, and a side that's 20 centimeters in length. And then we have this unknown x. We have to find the length of x. What case are we in? 1. Very good. We are in case 1, right? We have two angles and any side. We have two angles and any side. So we are in case 1. So what law do we use? We use the law of sines. You got it. We use the law of sines. So that means that sine of 30 degrees over what? 20, good, is equal to what? Sine of 135 degrees over? Over what? X.
I would label all the spots according to the.
You can change it, but make sure right now we're doing it with the variables that we have. Again, it's not going to matter if you use C or X as long as you know to translate that information in the end. Yes?
Can you also do 20 over sine 30?
Absolutely, you'll get the same answer. Just be consistent with your ratios. You can write 20 over sine of 30 is equal to x over sine of 135. Go ahead and do it that way. You'll get the same thing.
Okay.
The process now is to cross multiply. So you'll get x sine 30 degrees is equal to 20 sine of 135 degrees. And that means x is equal to 20 sine of 135 degrees over sine of 30 degrees. Now, it's possible for you to have this is just a side note, so I'm going to pause the video. Back here, so 135 degrees is the same thing as 3 pi over 4. What's sine of 3 pi over 4? Square root of 2 over 2. Good. So again, this is just an aside. 135 degrees is the same thing as 3 pi over 4. And again, if you're using a calculator, you can just enter it at this point. Yes?
So is it okay if we just kept it in degrees?
Yes, that's fine.
Okay.
That's fine. That's perfectly fine. But I'm telling you, if you need to do this, you're going to see the steps here.
Okay.
And 30 degrees is equivalent to what? No, 30 degrees is the same thing as what radians? Pi over 6. Good. Now, what is sine of 30 degrees? 1/2. Good. So, you have 20 times the square root of 2 over 2 divided by 1/2. Same thing as multiplying by the reciprocal, which is 2. Then that means that 2 would cancel with this 1/2. And you end up with 20 times the square root of 2 centimeters. So that's x. That's x. What questions do you have?
Can you repeat what you did with the 1/2 there at the end?
Dividing by 1/2 is the same thing as multiplying by 2.
Okay.
So you would have 20 times the square root of 2 over 2 times 2. Then these 2's cancel. What other questions do you have? Okay. Example 2. Example 2. Did you get everything from example 1? You did? Okay, good. So, now we have this triangle here. This angle is 75 degrees, this angle is 62 degrees, this angle is theta. This side is 10.2 inches. We need to find the length y. How do we go about finding the length y?
First you would want to find theta.
Very good. Very good. You want to find theta. And you want to find theta why?
Because to complete law of sines, you're going to need that angle specifically.
That's right. To use the law of sines, we have to find this because y is opposite this angle. Very good. So we need to determine theta. So we need to determine or find theta. How do we go about doing that?
You take the two angles and or the two angle measurements and subtract them from 180.
Good. So you have 180 minus the sum of 75 and 62. So you can just add those, 75 and 62. Subtract them from 180, and what do you end up with? 43. You got it. Good. So theta is equal to 43 degrees. So now we can fill this in. That's 43 degrees. So far, so good. Now, what do? Go ahead, tell me what to write.
Sine of 75 over 10.2 equals sine 43.
I'm writing too, remember. Sine of 75 over what?
10.2.
10.2. Make sure you write degrees where you need to have it. Equals.
Sine 43 degrees
Mm-hmm.
over lowercase b.
Go-
Y.
Good. And then you have,
Y would equal 7.58 actually.
so write it, not 7.8.
I would, sorry, 7.58.
So you have y sine of 75 degrees is equal to 10.2 times sine of 43 degrees, right?
Yeah.
And then you divide both sides by sine of 75 degrees. And what are you getting?
I got 7.58.
Did everybody get 7.58?
Well, I
So entering that in, you have 10.2 times sine of 43 degrees divided by sine of 75 degrees, and that's approximately 7.2 what? Inches. Good. Okay. What questions do you have? All right. Next, example 3. Example 3. All right. So here in triangle ABC, you are given what?
angle
Angle
C.
C is equal to 45 degrees. The side B is equal to 4 square root of 2 feet. C is equal to 8 feet. Solve the triangle. That is, determine the remaining side and angles. So given this triangle, fill in the triangle with the given information. How do we fill it in? What goes here? Oh, well, what goes here? You,
4 root 2.
which one?
8 feet.
I heard both. I heard 4 root 2 and 8 feet.
Oh, it would be
This should be, this side represents what little measurement? It's little c, right? So what goes here?
8 feet.
8 feet. Good. What goes here?
4.
Good. 4 root 2. Do we know the other one? No, so let's call it little a. And what angle are you given?
45 degrees at
At angle
angle C.
C. You know that's 45 degrees. Okay? Good. So what do we do?
Set up law of sines to find angle B.
To find angle B, you said?
Yes. Because if you find angle B, then you can find angle A by subtracting from length B, and then you can find length A.
You got it. Good. So let's make this smaller. We'll need the room. Good. So using the law of sines, you have sine of angle B over what? Little b, which is 4 root 2, equals what?
Sine 45 degrees over 8.
Sine of 45 degrees over 8. Good. And then that means sine of b is equal to 4 root 2 sine of 45 degrees divided by 8. Sine of 45 degrees is root 2 over 2. Divide this by 8. What is the square root of 2 times the square root of 2? 2 over 2 is? So this all is 1 in here. So you end up with 4 over 8, which is 1/2. You got it. So all of that to say, sine of B is equal to 1/2. Now how can you find B?
Apply sine inverse.
Apply sine inverse. Good. So that means B is equal to sine inverse of 1/2. And what is that? 30 degrees, right? $30. Good. Does that make sense? Okay, now what?
Find angle A.
Angle A, so we get angle B is 30 degrees. Angle A, you said? Angle A would then be, so you found B. B was 30 degrees. Now angle A, how do you find it?
180 minus 30 minus
180 minus 30 minus
45.
45, and technically you should have degrees every place here, right?
Yeah.
And what does that give you?
105 degrees.
105 degrees. So that's angle A. Good. So that's 105. Now, you have angle B. You have angle A. We found the missing angles. Now what do we need to find? Side little a. Good. How do we find it?
A over sine of 105 degrees.
A over what?
Sine of 105 degrees.
Mm-hmm.
Equals sine of,
Have to be consistent.
oh, I'm sorry, equals 4 root 2 over, well, if you went, yeah, 4 root 2 over.
Can you use a Pythagorean theorem here? Theorem here?
No, it's not a right triangle.
There you go. We're working with what kind of triangles? We're working with oblique triangles. Pythagorean theorem only applies whenever you're working with a right triangle. Okay, good. So you have A over sine of 105 equals 4 root 2 over what?
Would you just say sine of 30 degrees then?
Would you?
Well, you found B, we found B earlier, and you determined B to be 30 degrees, so.
Right. Good. Questions about that? We're not done though. Questions so far? Hello? Okay, so keep it moving. So we have A is equal to 4 root 2 sine of 105 over sine of 30. What do you get? To the nearest tenth. Good, you get 10.9 what? Feet, good. So, we filled in every side. So we get 10.9 feet. So we filled in all the sides and the angles. We solved that triangle. Okay? So that's using the law of sines. Okay? Now, remember if we fell into case 3 or 4, we have to use the what? Law of cosine, right? Now, one thing before we talk about the law of cosines, there is another case, okay, where you're given two sides and an angle opposite one of them, which we just talked about, right? This is referred to as the ambiguous case. Make sure you read about this on pages 510 and 511 in your book, okay? The law of cosines. Again, the law of cosines applies whenever you have three sides or what? Two sides and their included angle. Good. So, the law of cosine says the following. Now, typically, you're just given the standard form. I just decided to write the alternative form there for you. Typically, you're not given that. Okay? The law of cosine says, in any triangle, the square of the length of any side equals the sum of the squares of the lengths of the other sides, the other two sides, minus twice the product of the lengths of those other two sides times the cosine of their included angle. Mouthful. Mouthful. This, in words, is this mathematically. Okay? The law of cosines is this in words, this mathematically. Little a squared is equal to b squared plus c squared minus 2bc times cosine of the angle A. Little b squared is equal to little a squared plus little c squared minus 2 little ac times cosine of angle B. And then c squared is equal to a squared plus b squared minus 2ab times cosine of c. So notice that you have the square of the length of any side is equal to the sum of the squares of the other sides minus twice the product of those sides times cosine of the angle in question, the included angle. Does that make sense? You'll have to know that. Okay? Now, to get the alternative form that I've given here, all you do is algebraically manipulate this to get this. So you can subtract b squared, or to get this, you can, so it stays the same form, you can add 2bc cosine of a to this side, and then subtract a squared, and divide both sides by 2bc. Do you need me to write that? No, you said?
Yeah.
Okay. All right, so that's the alternative form, okay? Given this is your triangle, okay? So now let's go through some examples. Let's apply it, okay? Let's apply that. Example 4. Online, are you okay? Do you have any questions? Okay. So in example 4, we have this oblique triangle where we have two sides. We have these two lengths, and we have the angle, their included angle here is 120. What case are we in? Yes? 4. Good. We're in case 4. We're in case 4 here. We want to compute the length x, okay? Because we're in case 4, we have to use the law of cosines, okay? So, in order to find x here, we use the part that says x squared is equal to 7 squared plus 8 squared plus or minus? Minus, good, 2 times 7 times 8 times cosine of what? 120 degrees. Good. So that's equal to 49 plus 64 minus 16 times 7 is 112. Cosine of 120. 120 is the same thing, so 120 degrees is the same thing as 2 pi over 3. So that's the same thing as 112 times negative 1/2. Because 2 pi over 3 lives in what quadrant?
Can we keep it as just cosine times 120?
And again, my question is still going to be the same.
Okay.
120 degrees lives in what quadrant?
Two.
Quadrant 2, right? So the question can remain the same whether it's in degrees or radian.
Okay.
The question remains the same. You're going to have to remember the unit circle. You're going to have to know it. No way around it. Okay? So, simplifying that, that means x squared is equal to 169, or x is equal to the square root of 169, which is what? 13. So we get x is 13 centimeters. Good. What questions do you have? Okay. All right. So now let's go through an example where we have to find the angles. Okay. So let's move this up. In triangle ABC, the sides are A is equal to 3 units, B is 5 units, and C is 7 units. Find the angles. Use degree measure. The alternative form may be helpful here. You want a couple seconds to try it? A couple minutes to try it?
Sure.
Okay. So our missing angles are, as you said, 21.8 degrees, 38.2 degrees, and 120 degrees. Excellent. So now let's work through it and show that those are our angles. So we use the law of cosines. So you have cosine of A is equal to, and depends on how you label them. It really depends on your setup. So I labeled mine as A, B, C, and had 3, 5, and 7, like so. But again, you probably didn't label yours the same way, and you end up with the same angles. Okay? How you label it is entirely up to you. Okay? So cosine of A is equal to 5 squared plus 7 squared minus 3 squared over 2 times 5 times 7. That's equal to 65 over 70, or 13 over 14, which means A is equal to cosine inverse of 13 over 14. And that's approximately 21.8 degrees. All right, so you get 21.8 degrees here. And then cosine of B would be 3 squared plus 7 squared minus 5 squared over 2 times 3 times 7. That's 33 over 42, or 11 over 14, because they have 3 in common, which means B is cosine inverse of what? 11 over 14, and that's approximately 38.2 degrees. And do you have to go through that for the other ones? No, you can just take that and do what?
Add the 2 and then subtract it, or
Go ahead.
180 and then subtract it from the other 2.
Good. So angle C would be 180 degrees minus 21.8 degrees minus 38.2 degrees, and that'll give you 120 degrees. Those are your angles. What questions do you have? I'll leave it here. I see. So another concept that uses the law of sines and the law of cosines in navigation, okay, is navigation. Using the law of sines and the law of cosines in navigation happens all the time, okay? It is very important for you to go through your homework. You will see a lot of problems like this. It's important that you understand the different ones, okay? All right, so suppose you have your x-axis. So here's north, east, south, and west. Again, north, south, east, and west. Okay, suppose that you have point O here, you have a point P here. And then this angle is 45 degrees. We say that the bearing of P from O is north 45 degrees east. Is read as north 45 degrees east. So we use N for north, E for east, W for west, S for south. In part B, what's the bearing of P from O?
45 degrees south.
You said north, 45 degrees south. That means you're north, 45 degrees south. You can't get that.
Or west.
What is it?
And 45 degrees west.
N 45 degree W or west. Good. So N 45 degrees west, read as north, 45 degrees west. Okay? So note that the bearing is specified by means of the acute angle measured from the north-south line. Okay? Example 6. Two boats leave the same port at the same time. One travels at a speed of 30 miles per hour in the direction north 50 degrees east, and the other travels at a speed of 26 miles per hour in a direction south 70 degrees east. See the figure below. How far apart are the two boats after 1 hour? What do we do here? Yes?
Would you want to, I'm imagining this as a triangle where the S 70 degrees east and the north 50 degrees east connect by a line.
Where does the line go?
From S 70 degrees east to
Here?
N 50 degrees east.
From here to here?
Yeah.
Okay. I see a head nodding yes and you second guessing yourself.
We have the angles outside of that triangle.
Yeah,
So-
you can figure out the angle inside,
How do you figure it out?
subtract it from 90, or 50 from 90, and you get 40.
Do you even need to do that? That's finding out part of it.
No, you said.
How can you find all of it?
180 minus 120.
180 minus 120. You can get there the same way. You would just have to take 2 steps. You said 90 minus 50, and then you would do 90 minus the 70, and then you would find this is 40, that's 20. You'd add them. But you can also just do 180 minus 120. Good. So the angle, I'm just going to draw a red line there and say that the angle subtended by their directions is 180 degrees minus 50 degrees minus 70 degrees, which gives us 60 degrees. So this missing angle is 60 degrees. What else do we know?
The 2 sides,
We know 2 sides. What's this side?
30.
That's 30. Good. And do we know this side?
Yes.
No.
No.
No, that's the distance between the boats, right? So let's write D to be, let's say D is the distance between the boats in miles. And what is the other side here? 26. Good. Okay. So we have that information, and now what do we use to find it? What do we use to find D? Law of cosines. Good. We use the law of cosines. So that means D squared is equal to what? Walk me through it.
Is it 30 squared plus 26 squared?
30 squared plus 26 squared. Is that it?
Minus 2 times
times 26.
Cosine of 60 degrees.
Cosine of 60 degrees. Good. If you entered that entire right-hand side in your calculator, you're going to get d squared equals what? Good. You get 796. So that means d is equal to the square root of 796. Now, technically, when you take the square root, we've been doing this all along, but technically when you take the square root, you end up with plus or minus. But does the minus make sense in these cases? No, it doesn't. What do you get here? 28.2. Good. So that means that the distance between the two boats is what?
28.2.
Or approximately, you can say 28.2 miles or approximately 28 miles. Okay? What questions do you have? Now, these problems with the navigation become more complicated, okay? But it's all about knowing your bearing and being able to read it. You have to make sure that you understand this concept because it can be a two-part type of problem. I'm telling you to make sure you go through your what? Homework. Take advantage of it. You have a lot of days between here and next Monday. Yes, there's a question.
Can you go back up to the first navigation examples that we did?
Yes.